Hey, what's up, coders? I hope all of you are doing great. Few days back, I woke up and got a news that we will not have our digital electronics lab classes anymore. But I had to practice somehow, so I decided to create my own circuit simulator. Here's how. And I'm also working on an Android game. Stay tuned to know more about that. Getting back to a circuit simulator, let's understand first the mechanism. Everything is object oriented, so you must know classes, inheritance, etc. So there are gates, and each gate has its input values and output nodes. Output nodes are initialized to null as it's not connected at the first place. When we make the connection, the address of the next node is fed into the output nodes of the current with the index. And finally, in the operate function, it calculates whatever logic it has and sets the input value of the proper node. So I made a basic HTML page, linked the scripts, added some buttons. That's kind of boring, right? Let's do some styling. Now let's dive into the code. All the types of node are listed above. This is the basic node class with move function, set input function, and a show function to display the node properly. Then I extended the node class to create input output node and or NAND, NOR, XOR, XNOR, and junction, which basically spits out whatever gets fed into it. Now let's look at how I made it work. In the setup function, I created a P5.js canvas and parented it and resized it to fit the screen. In the draw loop, I just set the nearest node to my mouse pointer. This is how I did. Then on the key press, we are checking if you are hovering over the nearest node. If yes, then we perform the corresponding tasks, like deleting a node by delete button, renaming a node by Control A, and breaking the output connections of a node by Control B. On mouse pressed, we check which node we are clicking on or in which output or input positions. Accordingly, we move the node or we start making connections. And finally, on the mouse released, it cancels the line or make a connection. Until now, my life was peaceful. Then I decided to create a feature of adding node groups. This took me days. I'm really not capable of explaining this. Just to create a node group, I had to write depth first search algorithm or DFS and a reverse DFS algorithm to get the Boolean expression. Then I also added a save restore system so your hard work doesn't get lost. Then I had some spare time, so I added a 4-bit register and an SR latch. Added some more buttons to toggle the full screen mode and expanding the canvas and made it mobile friendly. Now let's see this in action. This is how you create a half-adder circuit. It works as expected and properly follows the truth table of a half-adder circuit. Now let's group this by clicking on the Create Group button and giving it a proper name without any special characters or spaces. This is the half-adder chip I just created. This hardware gets stored and you can find it in the buttons. Now let's create a full adder using two half adders I created. Output matches? Great. Let's also group this as full adder. Now using 4 full adders, we can create a 4-bit triple carry adder. Here what I made is clock operated 2-register based adder. First we wire everything up to the accumulator, which is the first register, and set some value. Let's say 1010, which is 6. Tick the store signal on, it gets stored in the first register. Now break connections and connect the inputs to the second register. Here we set 1 and tick the store signal on so that it gets stored in the second register. Now connect the outputs of the adder to the accumulator. The output still displays 6, but when we press the store button, nothing changes. Why? Oh, we forgot to hook the second register. Now when we turn on the signal, the output changes to 0110, which is 7. Hooray! Our thing is working correctly. If we leave the signal on, each time the clock ticks, 1 gets added to its previous output. Now this is a binary counter. This might be a bit overwhelming, but don't worry. All the codes are available on my GitHub. Link will be in the description below. If you like this video, please give it a thumbs up. Have any questions? Ask me in the comments. Subscribe to this channel for more such development videos. You'll not regret it. I promise. That's me signing off. Stay happy. Be nice to everyone. Bye.